So today we're starting Module 3, Lesson 1. And the title of this lesson is What Lies Behind the Same Shape? So what does it mean for something to have the same shape? Let's look at some vocabulary. We're going to start with the word that we learned previously in class, dilation. And dilation is a transformation of the plane from a center O and a scale factor that we call R. And R is always greater than 0. So this rule is going to apply to each point P on a plane. So just like we drew our simple figures in class and we labeled 5 coordinate points, each of those coordinate points was transformed through a dilation on a plane. So when the distance between the center and the point P is equal to the scale factor times the distance between the center and point P. So that's some interesting notation that we haven't talked about yet, so let's look there. That kind of straight line with the OP in the second straight line, that means the distance from the center P to point P. So I always have a center O, and whatever that first point is in your original shape, that's that distance. So when I perform a dilation, my scale factor multiplied by that distance between O and P should equal the new distance that I get between O and P prime, which is the resulting point of the dilation. So let's look at some similar figures, because similar figures, they have the same shape, but they're not necessarily the same size. And that's what we accomplish when we perform a dilation. We move one shape and we make it either grow or shrink. So that shape is going to be similar in shape, but not necessarily in size. So if I draw 3 sets of shapes here, I have a pair of triangles. Those are definitely similar because they're the same shape but different sizes. These rectangles here, which are not the same shape, so they can't be similar. And then I have another pair of triangles which are actually the same shape and the same size, which means they are congruent. We're going to move into Module 3, Lesson 2. And this is on the properties of dilations. And what we're going to work on is creating a dilation with a compass and a ruler. And we're actually going to see a demonstration of that in a moment too. So using a compass and a ruler, if I have a line, L, and on that line there are 2 points, P and Q, and then there's that center O that we've been talking about. In order to build the dilation, I want to use a straight edge to draw a ray from point O through any existing points like P and Q. And then I use a compass to mark the distance between O and Q and then extend it out to Q prime. And the same process goes for O and P, and then I extend that out to P prime. So you should always use a compass and a ruler to be exact. And when you do that, it looks like this. So let's say I start with this triangle and I have this point O, which is my center, and I want to make a dilation with a scale factor of 2. First thing I do is I draw my rays from my center O through each of the vertices of the triangle. So see how that triangle has 3 vertices or 3 corners, and I'm connecting all 3 of those corners with the center O and then extending them through the triangle. So that triangle, that's my pre-image. So what I want to do is take my compass and put the point on the center O and the pencil on the tip of the triangle. And then I shift it over so the point is on that tip of the triangle. And using the same distance, I put a mark on that first ray. Then I'm going to repeat this with the remaining 2 vertices. So see how I'm putting the point on my center, pencil tip on the vertex, and then I shift and mark. So I've got these 3 new points that exist on my rays that are twice the distance from my center O that the original image was. So not only am I twice the distance from O, I'm also twice as large in terms of my image. And as I mentioned, we're going to work on using a compass and a ruler starting next week, but I just wanted to give you a quick demonstration so that you're prepared.